A very good afternoon, everybody. I think many of the people here I have met yesterday in the booth. We have already had some conversation. This session is about TizenRT. This is a lightweight IoT platform from Samsung research team. We also had a demo booth, which I'll explain the demo scenarios. Before we get into the demo scenarios, let's go through the platform and its features. So let me explain a quick start on how we started with the backgrounds and trends and why we needed this platform. In 2015, we saw a global analysis done by the strategy analytics, and it said that the number of IoT devices, wearables, and the smart home devices were on a rise. And we saw that the enterprise IoT comprised of more than 50% of the total number of installations that was done. And also the forecast was for IoT and smart home, and is going to be more than the smartphones in 2020 or 2021. Also, the next thing which we did background research was where this IoT platform was progressing, mainly starting with the key trend and how the connectivity, increasing connectivity is improving, and which is leading to a connected environment, and that leads to the need of smart homes and what is the revenue related to it. So we thought that there is a trend which is requiring a standard IoT platform, because with these increasing number of connected devices, the most important was there was a diversity in the lot of IoT standards. So we wanted a singular platform which was going to bring most of the features that was required by these the progressing trends, and leading to interoperability between different devices. And we saw that the RTOS market was getting more popular than the other popular platforms in the market. But then there was an issue with the diverse number of RTOSs. That was that they had a limited capability. There are many RTOSs in the market. Few are the dominant ones, but they were not absolutely suited for IoT-ready platform. Some of the main things which we thought was lacking in an overall picture was there was no secure IoT data handling. Second was there was poor portability and extensibility, because these RTOS platform, they wanted to be light, they wanted to be targeting on the low-end devices, so they had missed a lot of abstraction layer, which is very important for portability of a platform when we are going into different chipset vendors and hardwares. And seeing the trend for artificial intelligence, we thought that this part was missing as a feature or as a support in the IoT platform. These missing features and the trend led to the start of TizenRT. RT is standing for Realtime. It's not a fork from Tizen. Usually people get confused with the name. It's a complete different project from Samsung Research. We released the first version of TizenRT in 2016, and it's basically a lightweight RTOS. And the key point was the Linux-style development environment. We had the real-time kernel. But over 2 or 3 years, TizenRT has evolved as an intelligent things platform with some advanced features like the secure IoT data handling, smart things, and voice service enabling. I'll be explaining about these features in the slides later. So first thing I would like to say is that we open sourced it. You can find this source code, full source code of this platform in GitHub. and under the Apache 2.0 license, which says that it's almost free and we don't have any restrictions. We already have more than 100 contributors as of now. And we released the Tizen 2.0 platform on last month of this year. So the advantage of open source is that we wanted the developers to have a hands-on with no cost, and it's easy to customize, and we will get the contribution from different developers all around the world. And one of the most important points for our open source was our collaboration with different partners. As of now, we have successfully open sourced or released with Arctic and Cypress boards. We are internally working with MediaTek, Expressive, and NXP. Soon, these code is going to be a part of open source. So the reason we are trying to target many chipset vendors is like we give the options to the developers. They can select any chipset of their type for suiting to their product and the cost, because the cost of these chipsets is varying. Some of these chipsets cost only $2 up to $30. So these are the low-end chipsets we have already ported the platform on. And if you go to Samsung GitHub, you can check TizenRT. You will already find the code for Arctic and Cypress. The next thing is the commercialization. So I think many people here doesn't know that it is part of many of the Samsung products. Is anyone aware that it is part of any of the products? So last year, we already shipped 3.5 million devices, which is a part of air conditioner, oven, refrigerator, washer, air purifier, and air dresser. In 2019, we are expecting more than 10 million devices internally, which is going to be shipped with TizenRT. So with a commercial products in the market, we think that we have already proven the reliability, and the quality is already established, and it is IoT ready. So one of the key features and the service that has been commercialized was the SmartThings SDK and service. This, I'm going to explain it to you that how TizenRT matured over a year to support for SmartThings and its connectivity with cloud, and how easily the applications can be developed for IoT. So before going into the details of SmartThings and how we support the voice and Bixby, I'll just quickly go through the core of TizenRT. What is the architecture? What is the features? And how we ended up in SmartThings. This is the overall architecture. This might be a little complex. In the later slides, I have divided the whole architecture into few groups so that we can have a quick discussion on that. We founded in 2015, and the first version of TizenRT was released in 2016. And we first commercialized in 2017 with our internal commercial division of digital appliances. The version was 1.1. And in October 2018, we released the TizenRT 2.0, which has the voice support, the Bixby support on it. So as you see that the overall division of the architecture is the basic kernel. We have the full-fledged kernel here, the lightweight real-time kernel. We have the core, which includes most of the network and connectivity part, also includes the fail-safe file system. That's one of the key features of TizenRT, which I'm going to talk about it in later slides. And we have the framework, which has a lot of features for the developers, like the database, which is going to be useful for reducing the IoT data collection. And we have ST-Things. We have the different kinds of task manager, media framework, etc. We'll discuss. So starting with some of the key features, we first focused, or you can say that this was one of the key architectural decisions when we started developing TizenRT, that we wanted a standard interface and portability, because we knew that this market is a very diverse market, and a lot of third-party companies, a lot of developers are going to have hands-on different kinds of chipsets. So it is very difficult for each developer or third party, or even for us, to support the porting of this platform onto various kinds of chipsets. So the main thing was the POSIX and POSIX compatibility. We wanted there are two things overall. One is the abstraction layer, which we have created for hardware, and one is the POSIX API. We have the support for VFS, the virtual file system, and we have the support for C++ language, which is from the LLVM library. So you can see from that the support of VFS allows us a good amount of extensibility because for now, we have the support for SmartFS. These are the file systems that the platform already has incorporated into it, but we allow the developers to add their own file system based on their NOR flash or NAND flash. Based on their the requirement, they can add their own file system under the VFS. So, and it's very easy to port the file system under this. So the reason why we chose was to save cost, shorten the development period, and to use the common stable features across platforms. Currently, there are a lot of platforms, there are a lot of open source platforms, a lot of open source libraries, and we want one library from one platform, and we want another library from a different platform, and we want to build up something. So that was what the simple example we have here is. We had the IoTVT protocol, which was developed on Linux. This is internal to Samsung. They had done the development here on Linux. And then we had the Bixby client, which was another software which was developed on Tizen. And we wanted to bring both of them to TizenRT. So this made us very easy. The porting is very easy to just include the libraries, because this also is Linux-based, and Tizen is also Linux-based, and we have POSIX support. So bringing in external libraries or applications is pretty simple for us. I think we did this port less than a month, and we did the testing, and we were able to release into the open source. Second was, of course, with IoTVT, connectivity and the network is pretty much important for TizenRT. So I have abstracted most of the details, but so key important features was the IPv6 support. Apart from the IPv4, we had the IPv6 certification. We have the proprietary supplicant, which is a part of our platform. But many chipset vendors provide their own supplicant. The supplicant is part of the library or the firmware in the chip. So in that case, we have the porting guidelines, so we have the flexibility to use those chipsets as well, so that they can use their own built-in supplicant. And we have the Wi-Fi abstraction layer, because nowadays we see that with many SoCs, the Wi-Fi is one of the key factors, and we want to use different chipsets for Wi-Fi. So the Wi-Fi porting is one of the, I think, challenging tasks after porting for the architecture. So we provided a Wi-Fi abstraction layer or utility layer, which helps us easy porting of different Wi-Fi chipsets onto this platform. Another feature was Linux-style programming. I already explained about the POSIX. We have the support for cell and kconfig. What kconfig does is it helps us in quick configuration and system sharing between different developers. We already have some predefined configurations for different applications. A quick tip that, like, if you are using this platform, and you can just take any of the configurations for any application and quickly change it and create your own application. The second was the shell, which is similar to the Linux shell. We have the Tizen shell called the Tash. Apart from the pre-registered commands of the shell, we have the runtime registered commands, which can be added by the application to be a part of the shell. So we give that flexibility, so each application can use their own commands to be registered onto the shell. And easy to develop. So we provided the IDE, which is called the Tizen Studio, or TizenRT has been supported onto this studio. So what it does is it's free, you can download, and it helps in auto generation of the code, the application as well as the platform code. And it also, like for example, you are trying to build any application for IoTVT, you can set up your own attributes and easily build Flash onto your board. So that gives a flexibility for the easy development. We have the support for the Docker, which helps us to build this platform on Linux, Ubuntu, Mac, and Windows. As I already told you, that this is one of the key factors where we wanted to have a reliable and fail-safe file system in our platform, because seeing the trend, most of the RTOSs wanted a real-time kernel, but we want to have data from different sensors and do some processing. But having the processed data for some time is very important. So for that reason, we chose reliable and fail-safe file system. So we added the journaling. So we had this MTD block layer, which adds the wear leveling, journaling, and garbage collection. So journaling was very much important for the SPOR recovery, that is the sudden power of recovery of data. It also supports the wear leveling and multiple mount point support. We also have the storage-based database, which is important for the IoT data manipulation. The important feature of this database is it's a SQL compatible interface, and it is portable to different file system or platforms, because again, it is using the very base is the VFS or the POSIX APIs. And to make it light and efficient, we have done some optimizations in the indexing algorithms and storage operations to make it tiny and fast. So on a summary, I think these are the key features which we discussed. I think TLS security is also important. I didn't mention in the detailed architecture slides for the connectivity and network. We have the POSIX and the VFS support. We have Wi-Fi support, proprietary supplicant, and IPv6 certification. We have the IoTVT protocol, the OCF protocol support, the SmartThings SDK and service support, and the journaling file system. These are some of the key features. We can discuss more if you. There are so many other features which is not possible to cover, so we can discuss it later if you can contact me. So with these development of these features, we were able to mature TizenRT to be supporting with the smart things, and how we were able to do it with these enabling technologies. TizenRT can be used to enable smart things on any IoT device as a controllee. So there are two basic scenarios here. You can use this platform, port this platform onto your device. The device can act as a controllee. This is the smart things case. And the next case will be, you can use the voice-based platform, which is basically a controller device, like the Samsung refrigerator and aircon, which we are going to be shipping in the future. Let me first explain about the smart things and how we can turn any device into a smart IoT device and act it as a controllee. So basically, we have these controllee devices, for example, a light, and if you want to take a bulb or any light and want to make it to a smart light, then it's very easy. Using the IDE, you can develop your own application, and you can have your chipset connected to this LED bulb, and we can use the IDE to simple build and flash the TizenRT plus your Things application. And using the Smart Things app on your mobile, which helps in easy registration to the Smart Things cloud, you can actually control these Things products. So till now, we discussed how are some of the important features which was driving TizenRT and how we matured into supporting for smart things and like easy cloud integration. But then we thought that the market is going towards voice-enabled services. So let's take a look on how the competitors are coming up and what is the market analysis and how we want to catch up with the growing trend of voice assistants. We saw that the number of households with smart home devices, including the smart speakers, are constantly increasing, and the forecast says it's going to increase by 2022. So we thought that these controls through voice increase the usability of things. We all have been talking about things, but the usability makes more sense with voice-enabled assistance. So, and we also saw that the voice-activated assistant devices are getting popular. So first we have the connected things, which I already explained. Then we thought that to include the voice-enabled services. And now we are progressing towards the intelligent things platform, which is currently Bixby-enabled on the controller Samsung consumer devices. Moving forward, we are looking to add more AI support onto this platform. So this is a very high-level architecture of TizenRT as an intelligent things platform, where we have already ported most of the parts from Tizen, which is supporting the Bixby, and we have optimized some of the components to support the voice-enabled service and to fit in for the lightweight structure for the TizenRT. So the building blocks for the Bixby client engine in the TizenRT Intelligent Things platform are the support for HTTP2, TLS, Authentication 2.0 protocol, and voice communication protocol. The building blocks for the media framework inside the TizenRT Intelligent Things platform was the addition of speech detector, which has inclusion of the wake of word detection, voice commands, etc. We have included the support for different codecs and the basic player and recorder for any media framework. Let me quickly go through what we have done the demo on our demo booth and what is the significance of this towards the evolution as an intelligent things platform. So this is the basic user scenario that we can enable. This refrigerator is based off TizenRT, which is a Samsung refrigerator, and this refrigerator is going to act as a controller, and it is Bixby and voice enabled. And we have other things, products around our house, like a TV or a smart speaker or light. So we can issue the commands to these Samsung products, which now are acting as controller and control the other devices. Like we can give the command to the fridge saying that to turn on the light in the living room, or to turn on the speaker, or to switch to different channel on a TV. So the demo setup which we showed was we had a replication of all these products which are based off TizenRT. So we can go tell these products as hi Bixby, and we can issue the command like turn on the light, and it turns on the LED light. So basically what TizenRT offers to you is what we are going to discuss, like what are the key benefits and what is the readiness of this platform. As I've already explained, the most important thing is that you can build the IoT world with a lot of TizenRT-based chipsets. We have already ported TizenRT into various processor chipsets, like we are supporting Cortex M3, R4, M4, and currently we are working for Cortex M33. So looking into the wide range of chipsets, the developers and the third-party partners have the options to build their own products based on these chipsets. Second is overall it's an open source platform. It has been commercially proven, and the design and architecture is such that it is extensible and portable for different applications. And with increasing number of platforms partners, we can ensure that we are able to create that ecosystem in a long run. And since TizenRT is evolving as an intelligent things platform, for now, we have already been developed with voice-enabled services, but in going future, we have plans or we have internal development going on, adding different AI support that is in the roadmap to be added into TizenRT. So I think the key features are the IoT readiness and the support for the smart things and the voice enabling service. For a developer point of view, we have the portability, easy APIs for development. Maintenance is definitely low because of the abstraction layer for application and hardware, which I have already explained. And open source, there is no cost. It's Apache 2.0 license, so it can be just downloaded and you can customize and use it in your products. And with all the enabling features, I think you would like to explore the readiness of IoT products. You just download the code and write your own application using the IDE, build Flash onto your device, and you can even sell those devices. So I think the readiness is very much important. We have make sure that you have the end-to-end support, like free download of the platform code to the easy development of the application, and easy support for different architectures and processors, and build Flash, and the total end-to-end, like from the code to the product, it should be ready and it should be easy development. And the realization of voice-based applications. For now, TizenRT has been supported for the voice-based Bixby solutions, but that is only in the Samsung products as a controller. But we have the media framework already. So future, I think it is going to be open as an SDK, and the developers can develop their own application based on this free platform to have more voice applications. And last but not the least is with the SmartThings SDK and the service, you can connect to the Samsung cloud with a free registration and control your devices through cloud. You can check out more details of this demo and more in-depth one-to-one discussion with me. I'll be happy to discuss more and help. Thank you. If you get a chance, please rate this presentation in the application. Yes.
You talked about TizenRT.
Yes.
To get started with this, can we use this on the Arctic boards, or are they completely different from the TizenRT software?
Arctic 053 is the first chipset where the TizenRT was developed. So if you want to use this platform on Arctic, it is like the most easiest thing, because you just download the code and use the predefined menu configs. For example, you want to just start and check your shell is working on your product or not. Just you have the menu config, make menu config and the shell, and build it, flash it on Arctic, and it's going to work. And you can issue your commands on the shell and on your product.
So still TizenRT then would maintain its real time. Is the kernel going to be still real time in these IoT platforms?
Yes, so we have made sure that we should maintain the time deterministic nature of the kernel. So there is that code has been already implemented in the kernel. so that we don't go into the infinite loop of nested interrupts. And so we make sure that any task is time deterministic.
So all these services added on top of the kernel, say voice services and all that, is there any specific recommendations from you that if you use certain set of services, the real time is guaranteed, and some other services may not actually apply the real time sense?
Coming to voice, it's actually tricky because a lot of processing is done. There is a different Bixby server. I think the Bixby team can tell you the details of the real time of Bixby service. But as far as I know, that there is first, it starts with the hardware detection, and then it goes to the speech endpoint detection, and then it goes to the cloud server, Bixby server, that the processing happens, and that goes to the smart things cloud and goes to the things devices. So it's from the platform point of view, we cannot ensure the complete, I mean, it's of course real time. Bixby, you say hi Bixby, it responds. But from a platform point of view, we cannot ensure the service real time. The real time is from the kernel side. For example, if a task is initiated, a kernel task or a user task on the platform, for example, you say there is a Bixby voice task has been created. So any interrupt on that task will be time deterministic.
Okay, thank you.
Hi, two questions. Number one, our device is mainly based on Scilabs, the Silicon Labs devices. What's your timeline for the integration with that? Question number two is, our devices is also working with other third-party platforms like Amazon or Google, and I believe most of your devices is working with them as well. So if we develop the devices with Tizen, how does it work with a third party?
Okay, the first one is the timeline, you mean to say to port the platform onto the chip. Yeah, that is our main architectural decision into making this architecture. So internally, currently we are working on porting the code onto MediaTek. The chipset we are working on is MT7686. It's going to be open soon. And for us, it took almost only 3 weeks for the whole chip to be ready. We just ported. It's the Cortex R4 architecture. So the architecture is only there. So all we have to do is we have to just port the BSP code, the hardware code, and the peripherals. Like even all peripherals you don't have to port. Maybe just the I2C, I2S, and UART just for flashing, and port the few drivers, and it's done. So 3 weeks, I would say 1 month, you can easily port this platform onto any new chipset and get it up and ready. Sorry, what was the second question?
The second question is, if we develop the platform, how does it work with third-party platforms?
Third-party platforms,
like
cloud?
Amazon or Google, yes.
We already are working with AWS, so that is possible. But from the platform point of view, there is no specific collaboration as of now with Google or Amazon. There might be some internal developments, but I think it's not concrete yet. So working with third-party cloud platforms, I think for now we are going to connect to only SmartThings Cloud or Samsung Cloud. Any more questions? Mike, you had some questions yesterday?
What do you believe is the smallest architecture processor that you could run this RTOS on?
It's a very good question. So we have tried porting onto 512 MB of RAM. Like the total device is only 512, and the whole operating system is running on that. So even lesser than that, we have tried, but that is not open source. It's a commercial platform, which I cannot disclose here. But even less than that. So 512 is the minimum. So the MediaTek chipset, which is MT7686, is 512 RAM. So with that much RAM, you can easily run, because the core kernel is only 10 kilobytes. And then the Wi-Fi and IoT protocol, these things take a big chunk of memory, because Wi-Fi is pretty standard, like 2.4 BGN protocol, and the stack and the firmware is pretty much standard. And you need some more space for the FOTA and the bootloader. So the platform, the Wi-Fi, FOTA, and the bootloader, that's all you need on the overall package. And with 512, it's easily. So you get like even 2 GB RAM chipsets for $2. So 512 is even cheaper. Last year, STC, we had a demo. We demoed the light, which we are controlling through phone. So I think if you want to convert your light into a smart light, you can take a very cheap chipset. I think that's your use case, right? We can take a very low-end chipset, which just supports, I think Cortex M3 is also fine. We can take a Cortex M3 chipset and with minimum amount of RAM just to run comfortably for the platform and an application. Light application will be very simple, like controlling the light and dimming and increasing the brightness. That's all. So I think that's going to happen even less than $1. So you can convert a light into a smart light in very cheap price. I think.
That's the idea.
Any more questions? Yeah, thank you. Okay.